Yeah, so like today we'll be working with one second. Yeah, so today we'll be like implementing whatever we learned today in drones, what we learned yesterday in drones, and before that we'll be starting with the basics, like what all things you need for navigation and what all things you need for control. So first thing we'll be like to introducing to you is about ground stations. So there is a ground station called Q Ground Control, which you need to download. Uh, admit. Yeah, so which you'll need to download. So you can just type ground control download and it'll redirect you to this website. Here you go to Ubuntu Linux and you can follow these steps over here. So you just need to run these 4 commands and then you can download this app image. Since I've already done it, I won't be doing it again. And then this will be in your download folder. You can just make it executable and it will run properly. So I'll go to my downloads and yeah, so I'll run the qground control. For that you'll just you have to just dot slash qground control dot app image, and you'll also find it. If you want to find it, you can find it here. This is the qground control app image. So when it opens, it will show you a random map, which is nothing but it. This will be a simulation environment for now, and with qground control you can do a lot of things. So we'll be launching our Ardu pilot simulation now. So for that there is a website, like not a website. You might know about GitHub. So Aero Club has a GitHub, and you can go to the GitHub page. I'll just send the link in the chat. Yeah. So for Ardu pilot section, we have three commands. We have three commands right here. So the first one is used to launch Ardu pilot. So you can just copy this command and directly paste in your terminal. So when you do this first time, it will take a lot of time, but then it will start running the simulation. So this is basically your software in the loop, and yeah, so it will take like, yeah, Akshat will explain what a software in the loop is.
Yeah, so hi guys. So I'll tell you basically what a SITL software is. So have any of you heard of, okay, tell me in the chat if you know what a PID is or if you've heard the name PID. Anyone? So you might have heard it in the context of some control or something. Okay. So yeah, yeah, exactly. So he, we actually have the complete definition of a PID and everything. So we don't have to worry so much about what a PID is and what it does. We just have to understand how it is being used here. So the way this happens is that in Gazebo, you will see that there is something called frames per second whenever you open the Gazebo window. And the way that runs is that there is a certain code that runs at a particular frequency, and that code is keeps on running throughout time, and that creates a simulation basically. Because like how do you simulate something physical? Like in any physical environment, there are a lot of things that are happening at the same time. So the SITL software basically breaks that down frame by frame, and that software keeps running in the loop to create the simulation. So that's basically what happens. And the PID in particular, what happens over there is that it takes in certain values, and it basically it's a cause and effect relationship. So let's say if you have like you guys would have worked with energy curves in JE, and the online guys would have done it in their school and stuff. So the way that happens is that you would remember that there was balanced equilibrium and unbalanced equilibrium. So what a PID controller basically tries to do is that it tries to keep you at one particular place without having you slide off by making small or by making like the specific motions for that. So in that way, if you imagine a quadcopter, it is a very unstable system. Like, okay, for one, it can fall over. Then let's say if one of the fans starts spinning faster than the other four, it will basically pitch that side up, and the whole thing will start moving towards the opposite side. If you have, let's say, one fanlet underperforms, then you'll have it happen the other way. So the way we deal with this is that the SITL software basically keeps track of this, and there are sensors. So in the real world, what would happen is that you would have a Pixhawk on your drone, and that Pixhawk has a lot of sensors. It has what do you uh, yeah, it has gyroscopic and other sensors. So what happens over there is that it'll take feedback, and it basically creates a feedback loop over there. So if let's say one side is pitching too hard, it'll make the propellers on that side fly rotate at a higher RPM, and that will basically control and stabilize our drone. So now doing this in Gazebo, where we only have access to, let's say, the motors. So okay, one good question you would ask is why Mavros, right? Because we have basically made Gazebo right now. From Turtles, and we saw that we can simulate, like, let's say, a motor or something in Gazebo. So why do we even need some, like, we can make a subscriber and publisher, we can move the four motors independently. So why do we need Mavros? And the answer to that is because Mavros is a suite that provides us the complete control of the drone. So we don't have to worry about how much each motor is firing. We don't have to worry about all of these things. And Mavros will provide us some kind of like higher level commands that with Mavros our command can be go from here to here. And on the other hand, from the motors, the command is, let's say, instead of 1 ampere, take 1.2 amperes through the motor. So that way we have higher level commands and we have more control over our drone in general. So yeah, that is basically what SITL is and how these simulations work. So Pranit, you can carry it forward now.
Yeah, so that is like a very long explanation of what SITL is. So okay, so when this starts running, you'll see like MAV and a greater than symbol written. So that is nothing but the flight mode right now. We'll get to it afterwards. And so now you need to you can't visualize all this technical stuff. So what you can do is we have Gazebo simulations ready. So you can run this second command here in next new terminal. So just run this. This will take some time depending on your system. So it will load a Gazebo map with a drone inside it. Yeah, so right here we have our drone. So if you can't see it like properly here, so this is our drone here, and we will be like controlling this with the help of Ardu pilot and the ground station that we saw. Now when you launch the simulation and the Gazebo environment, you'll see there is a ready to fly status here, and this is your drone currently. So now let's come to the ground station. So what ground station basically is that it will have all your data regarding your position of the drone, the velocity, the altitude. As you can see here, like there is a altitude, then this is the airspeed, which is like the vertical airspeed. This is the time of flight. This is the horizontal airspeed, and this is the position from the start point. So all these parameters and many more can be taken care of from the ground station. Uh, since this is a simulation, we need not care about battery much. But when you do this in real life, so the use of ground station would be the same, and your flight controller, which we use is Pixhawk, so that will have Ardu Pilot or PX4, which is like another SITL, but we'll be using Ardu Pilot. So that will have Ardu Pilot installed inside the flight controller, so you won't need to launch that again and again. And also you can use ground station through wired or wireless means. Here, okay, this is the flight plan which we can use. This is the takeoff button and this is the return button. So flight plan is like you can plan waypoints and do it. So we'll be doing that later in this video. Takeoff is it will just take off to certain altitude, which we'll just do in a while. And return is like, let's say your drone gets lost or you want it to come back to the launch point, so you can just switch it to return mode and it will come back. But there is like one thing to notice here, that it should be in the range of communication, otherwise it's not possible. So yeah, now coming back to the Gazebo terminal, sorry, the Gazebo. Yeah. So now, since we have launched Gazebo and there, yesterday we were talking about topics and messages. Not yesterday, I mean in the last session. So we have something called Mavros. So Mavros is nothing but it's like a, you can say, it contains all the topics that are needed for drone navigation. So you can use the third command on this wiki, and you can just launch it. So it, yeah, keep in mind this will only be launched if your SITL and Gazebo are running. So yeah. So if there are like no red lines or something, your Mavros is running properly. And to check that, you can do a ROS topic list. Now, since we didn't run any ROS like topic which we ourselves made, so we will be able to see ROS out and all the Mavros topics here. So all, I'll just zoom it a bit. So all these, yeah, so all these topics are given to us by like Mavros, and you can use these topics for navigation. So all these topics have a unique use, and obviously you can't learn everything. So like we will be just telling you the important ones here. And about this, if we have time today, we'll be going to the code as well. And if we do not, then maybe we'll do it in the next session. So one of the topics which is useful, okay, yeah, right here is the camera image captured. So if you have a camera attached to your drone, it will, the image capture topic, you can use it to like send or receive images, or like as you all now know, publishing and subscribing. So it will be used to publish or subscribe to any camera image that is there. Also, like if you want to see what type of output or what type of message it will use, so as we learnt in the last class, let's just do a ROS topic info on the camera topic. Yeah, so this is using a message type called camera image captured. Also, with Mavros, we not only get topics, we also get a lot of messages, pre-made messages. And so let's say we have a camera on a drone and we are using this topic for communicating or subscribing and publishing to an image. So like yesterday we used a string type of message. So if you want to know what this message is, so you'll do a ROS message show and this message right here. So this will give us all the message, all the things that are there inside a message. So first thing we can get is the orientation, then we can get a geo point, geo which is latitude, longitude, altitude, and then we have our relative altitude, image index. So right now, if you're talking about only the image, the only thing relevant to us is the string file URL. So this works like the image is being uploaded somewhere and the URL is being given to you. So it works like that. Obviously, we cannot transfer images in text way. We cannot encode it in that way so that we get a image. So because of that, a URL system is used for images in ROS.
So, like basically, when images have been transmitted through ROS, they are sent in the form of a message. And if you want to use them, so if few of you have worked with say computer vision or something before, you know that images are stored as arrays, right? With pixel values, and each pixel value denoting a specific number corresponding to that color. So if we want to get that kind of output, we need to use some alternate bridges between them. So yeah, ROS also has this thing called CV bridge, like which helps in converting ROS messages into, so basically images which are sent as ROS messages into like OpenCV images, and there are even ROS messages help help you which help you convert those ROS messages into webcam also. So like you'll be able to use your webcam and convert that into a ROS message and also send it to the drone. So
Right. Now coming to the navigation part. So uh, we have our position. Many of the topics can give us position. So we'll use local position for this, of course, because global position can be problematic. So local position just like takes the reference of where you are starting with. So here you have your acceleration, odometer, pose, and all these stuff. Then about velocity, you have your set point velocity CMD underscore well. We had this similar thing in Turtle Sim. So if you want to change a velocity of your drone using ROS, so what you can do is you can just alter this topic, and for that you can either use like a long code which we used yesterday or ROS topic pub. I think we missed the ROS topic pub part. We'll be covering it whenever we go through the code. And this is for velocity. And okay, one more thing. So when you use local position for, let's say you're using a local position command for your position. So what happens is it will feed your position, but you need to set a destination where you want to go, right? So for that you will be using a set point position local. This is your topic which we will be using for that. So now what this topic does is it will give a definition, it will give a destination point of where to go. And yeah, Akshat wants to continue from here.
Yeah, so this is basically the advantage of having something like Mavros. So imagine if we were controlling the individual input of the four motors like input current and voltage, then how difficult would all of these commands be? Like even CMDVL, that is we decide the velocity, altitude, everything. All of these commands would be impossible basically. You can't basically just tell it to go from here to here. It would it would take in the individual motor input, then it will take the individual, like it will take in the sensor input, and it would be very complicated. So Mavros basically eases all of that for us. Yeah, Ayush wants to say.
and also like when you saw the like ROS messages which were displayed on the screen, you saw a lot of data structures inside that, right? Like float 64 latitude, float 64 longitude. So if you're making a message manually, like without using Mavros, you would have to, number one, you have to make the struct, I mean the message which you're sending like properly, and then you will also have to write the code for how to communicate it with ROS. So Mavros like eases that out a lot for you. You just need to write the name of the message and you have.
Yeah, right. So now like uh, we were talking about the set point thing. So yeah, so let's say you want to go to some place, let's say 2 comma 0. You want to go from 0 comma 0 on the same altitude, but on in real life or even in Gazebo, since the simulation is like very close to real life, there will be a lot of winds or some disturbances. So it might be that your drone can never reach that exact point that you mentioned. It will always be like there should be some threshold for that.
Yeah,
So
so if you guys have ever used Python, then you know that if you add like 0.1 plus 0.1 plus 0.1, it gives 0.3, then something, 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 and then something else. So basically, floating point comparisons work very, very badly in most programming languages. So the reason that we cannot just do set point position and do everything basically is that like these floating point comparisons aren't very accurate. So let's say what you would want to do is let's take it to 2 comma 2, let's say, and then it would never actually attain to 2 comma 2 because it is like a 16 point decimal after that. So it is very impossible to go to like direct exact positions, and so we basically work with a small like a sort of a golden value. So, that is what we do. So, let's say you have like 2 comma 2. So you would take a sphere of 0.01 meters, let's say around it. So 0.01 meters is what? 1 centimeter. So 1 centimeter sphere around it. And as long as the position is within that sphere, we assume that the position is that. So we basically, when you guys later on, if you study this, it's called discretization. So if you later, like we just use a function like if you are inside the sphere, then you are in. If you are not inside the sphere, then you are out. But there are like for those of you who will be in the projects and everything, and if you want to do this further, then we use better functions such as sigmoid and tanh to basically attain these points. Yeah. So Pranit, you can carry.
Right. So yeah, so like how we will be using this is you can use like a, let's say 0.1 meter error phase, and you can do whatever is the output of your local position minus your destination. So that should be less than, if it is less than 0.1, so it means that your drone has reached the vicinity of 0.1 meters from your destination. So if it reaches that, you can say that the destination is reached. So that is how you can work with the pose system. Moving on. Okay, so now I think we'll go to the ground station, working of the ground station. So here you can take off. So you just have to click the takeoff button. You can set your altitude here. We'll just go like standard 10 meters or something. And we'll, for takeoff, you can slide this button.
Guided flight mode. Armed.
So I don't know if my audio is being shared, but you heard that there was some guided flight mode on. If it's not, then it's fine. I'll just tell it to you what that means. So you can see that our drone has reached like 10 meters above, and yeah, and here also you can see the altitude is 10 meters and current speed is 0, and it is varying because of the winds and all, which is like close to real life scenario. So this is how you take off a drone using your ground station. Now you can also do this using your SITL terminal, which is, look, I'll show you that. First you need to land your drone. So what you can do is, there is now, like I told about return, so you need your drone to come back at the position from where it was launched. So you can just press return and you can slide it.
Return to launch flight mode.
Now this is called RTL. So it goes up to a certain altitude, then it will loiter there. Like it will just stay there for a few seconds, and then as soon as like the landing space is cleared, it will start landing and it will gradually land on the ground. So this is how an RTL works. This is very useful in when you fly drones in real life, because many times, even to us, it has happened that our drone, like it flew off somewhere it wasn't intended, so we just brought it back to RTL mode. So yeah, it is life saving. Yeah, so as you can see, it has almost landed. Yeah, so it has landed. Now
Disarmed.
coming to the Ardu Pilot terminal. So if you press enter here, you can see it's written RTL. So that is the flight mode. So if you want like the list of all flight modes, you can just go to Q ground control. Here you can see RTL, and there is some wavy symbol over there. So these are all the flight modes that are available in Ardu Pilot, and you can use any of them. So I'll just tell you a few of them which are important. So stabilize is basically when you control the drone manually using a remote. So that is what stabilized flight mode means. So if your drone is on stabilized flight mode, any of the computer commands you give won't work. Only the remote throttle will work. Next is altitude hold mode. So let's say you're flying a drone and you give it a sudden throttle, and if something happens and you want it to hold that altitude, you can just quickly switch to altitude hold flight mode, and it will hold that particular altitude like wherever it is. Auto flight mode is if you have like a ROS script made, or like a waypoint plan path on QGC, which is Q ground control. So you can use auto flight mode if you want to execute that. Next is loiter flight mode. As I said, loiter is like just moving around 1 or 2 meters on that point, so that uh, so that if you want to do something or you want to make sudden changes in your plan or something, you can just put it to loiter. RTL, as we discussed, return to launch, and circle is, it will make a circle, and I don't think anything else is necessary to us. So these were about the flight mode. So you can change the flight mode here. by typing mode space the flight mode name. So I'll put it on stabilize.
Stabilize flight mode.
And as you can see, the mode, you can see when you press enter, you can see that the drone is gone into stabilized flight mode. You can also arm your drone from here, or if you want to see all the commands, you can just put help. So these are all the list of commands that are available on the Autopilot terminal. Um the I think the relevant ones will be arm and disarm, and your flight modes obviously. So now you can arm your throttle. So if I'll just keep the terminal on top so that you can see the drone as well. Yeah. So here is the drone, and to arm your throttle, you can just type arm throttle.
Armed.
So as you can see, the motors have started spinning, and in real life also, when you arm your drone, it shows that it is armed. So
Disarmed.
the motor spins in like a very low speed, so that you know it is armed. Then there is one thing called arm safety, but it is not present in simulations because you don't need safety for that. So what that is there is a button on the drone. So if you press that button, then only the drone can be armed. So that is what arm safety is. You can trigger that also from here if you have a real drone. So you can just put arm safety off and safety on, and safety off as well. So that is how it works. And yeah, now if you want to take off from the terminal, so first of all, because you are inputting computer commands, you need to put it in mode of guided.
Guided flight mode.
And you can see on the QGC also that must have changed. Yes, it is showing guided over here. Now you need to arm your throttle, and then you can take off.
Armed.
And for takeoff, you can write just takeoff and the altitude which you want to go. So it has started takeoff now. And okay, one more thing, if you're wondering what this blue thing is, that is just a lidar sensor, and I think Akshat will be able to explain more about it.
Yeah. So not so much about the lidar sensor first, but why some of you would wonder why are we doing this, right? So why are we entering terminal commands to do this when we can do this in QGC? So basically, what will happen is that when you have a real drone, you will have an onboard computer on it, and so you can basically run these very commands on an onboard computer, and you can basically create something like a bash script, which is like a terminal fancy word for a terminal script, and you can create a script like that which will just do all of those commands, and we'll be able to guide the plane. And okay, so Ayush want to explain about lidar.
Yeah, so before I explain about the lidar, just some few points regarding the microcomputer also. So, like Akshat mentioned, you'll only be able to see the terminal of the computer on your system. So, using Mavros will be much better. So, like the microcomputer which we were using on our drone was a Jetson Nano 4 GB RAM. So, when we tried running QG, like when we tried running Q ground control along with along with the ROS framework, it used to crash because like 4 GB RAM is not enough to support that. Apart from the other algorithms like the computer vision algorithm which it was running for something else. So instead of QGC, we were able to directly access the terminal and like run our commands from that. So that's that.
So about the lidar thing. So the lidar is basically something like a sensor, right? So we usually deal with either 1D, 2D, or 3D lidar. So usually this 1D or 3D lidar. So what 1D lidar is that what lidar does is it is basically like a bat basically. So it emits some light and it looks at the reflection from that light, right? And using that, it maps out. So it's basically like you have two eyes, and you look at the difference between the output from these two eyes to basically tell to be able to do depth perception, right? So that is what lidar does, and that is also kind of the reason why it doesn't work in fog or in smoke. So we use lidar to basically tell our location, and we sort of build like a complete path. Like from where we started, we build like a complete 3D sort of world of where we are in, and we can do a lot of things using that. We can do exploration, we can do navigation, guidance, everything. So yeah, Pranit, you can carry.
Yeah. So lidar is just like as Akshat said, it is used for avoiding obstacles and stuff. So yeah. Now moving on this. So this is how you use the ground station and the Autopilot terminal. Also, yeah, you can use your Autopilot terminal for moving here and there without like any code or something. So wait, I'll just open my Gazebo window. Yeah. So as you can see, the drone is here right now. So if you use like here in the help, there is a position command. So I'll tell you how to use this. So you can just type position, and then it is XYZ. And I think it also has a parameter for angular velocity. I'm not sure about that. We'll just try it out. If it's there, then it will rotate also. But yeah, let's see. So if I want to move like 5 meters ahead, so you can type 500, and yeah, so it has went 5 meters ahead. Similarly, if you want to go to, let's say, like 5 meters on the y-axis, so you can put x0 and y to 5. So you can see the drone has gone 5 meters to the right. And I'll just try out the I'll just try out the angular velocity as well. So it should be like omega. Okay, yeah. So it just uses xyz for. So this is how you use the position command. Now, if you want to like make it return to launch, you can just type here mode RTL,
Return to launch flight mode.
and it has gone to RTL, and the drone will be now going to where it started. So this is like basically how you control a drone using a computer, and like, this is a very basic idea of how you do it. Now, about path planning. So we'll go to our QGC. Also, in the QGC, you can see the. Wait, I'll just try to zoom in. Yeah, you can see how our drone went. So this was when it went forward, then it took a right turn over here, and then it returned to launch. And this is the launch point. So this is how the drone went. So you can see that also here. Now coming to, okay, let this land first. Yeah. So now,
Disarmed.
yeah. So moving on to path planning. So you can just click this plan button. Now you can let this map load a bit. Yeah. So if you want to, so there are 4 options available. And okay, so one issue with this is when you're using Autopilot, so you can't really use the structure scan feature because it is more optimized for PX4. But if you want to use it in Autopilot, or if you want to use it in Mission Planner, which is a similar thing to QGround Control, and Mission Planner works better in Windows, I feel. So if you're using Autopilot plus Mission Planner, so the structure scan will work well. And if you're using QGround Control with PX4, then it will work here as well. But since Autopilot is really easy to install and to learn, so that is the reason we are moving forward with Autopilot. So now how to plan a mission here is like just go to a blank page, and here will be all your elements of your mission. So first thing we need to do is take off. So we'll put on like click on the takeoff button, and takeoff altitude, let's set it to 15, and done. So that is the takeoff. Now you can add waypoints over here. So let's say I wanted to make a square out of it. So this is one waypoint, then two, then three, and then I'll from here. Now since you have made this, now I can do a return to launch over here. So I'll just press return now. So it will come back to the launch point. Now if I go to here waypoint, this altitude is set to 50 meter, but I don't want it that much, so I'll just change everything to 15, all the waypoints. and 15 here too. Yes. So now here what you can see is this is your altitude versus the actual terrain altitude plan. So if you're doing this in if you're doing this in real life, let's say at C5 or like NAC or something. So if there is some hilly area, this green line in the bottom here, this will increase if the actual altitude of the Earth is increasing over there. Since the runway is flat, more or less, so this green line is straight and return to launch. Now once you've made the part, just make sure everything is correct. So your mission should start. Also your initial waypoint alt, I have to set it to 15. So takeoff is at 15 and all the three waypoints are 15 and return to launch is also there. So this is a very basic flight path. So now you can upload it on the system. Now what uploading means is here in simulation we don't have anything physical to upload. But when you do it in real life, so you have to upload this path on your flight planner. So that is how the plan will be executed. So you can just upload it. Now it will say done here. If there is some clash with the altitude over here, so it will say that there is some error. Now you can click on fly and this waypoint will be loaded over here. So I'll just reduce the size of this window. Yeah, and this is our drone right now. Uh, yeah, so you can just slide to confirm.
Guided flight mode.
And as you can
Auto
see,
flight mode.
it went into auto flight mode because it is using a computer controlled path. So now it has taken off to 15 meters. This green is the 10-meter mark. So it is taken off to 15 meters. Now it is going front. And as you can see, the velocity is like pretty high. So there are a lot of parameters which I'll be explaining you after this path is completed. So that is how you control the speed or anything, because in real life if you see 7 meter per second is like very high if you are flying it in an urbanized area or something. So yeah, now waypoint 3 is completed and it will go to waypoint 4. Now if you look at here, the drone went from here, and from here it will go back to the launch point. Now it will switch to RTL mode and then it will go to the launch point and then it will land. Okay, so landing will take a lot of time because it has to be done very slow. So moving on here, so this has like 3 parts in it, the queue which is here. So vehicle setup. Okay, also we as we shared in the first session, we'll have an actual drone building stuff and implementing all this on a real drone in, I think it was October, I'm not sure, I don't remember actually. So we'll be doing all of this on a real drone at that time. And yeah, so I'll show this to you, but the drone has to land before that, so let's wait for it. Yeah, so the drone has landed and
Disarmed.
it shows that the flight plan is complete, and we'll just remove the plan from vehicle. Moving on, if we go to vehicle setup, this is where the actual like the aspects of a drone you can say. Yeah, so this is where the frame is quad, type is X. X is like when your front direction is between two arms, then your radio and all. Yeah, so everything is connected right now, of course, because this is a simulation. Then there is firmware, frame, radio, yeah, flight modes, sensors, power, everything. This is like uh, you can use this to program your drone. So that is how it works. It is not really relevant in the simulation, but yeah. So that was it about the drone navigation, and I think now you guys can experiment it with different paths. Also, if you go in plan mode and blank, there are a lot of options here, which is like you can use all these options and you can make your own path and try flying your drone in the autopilot simulation. Okay, and one more thing, if you want to close this, then what you should do is you should press control C in every terminal, because if you close it without that, it will not start again, it will throw some
Communication lost.
errors. So okay, these two had nothing. And yeah, so this is how you like end every terminal. So as you can see, everything has been closed, and I don't know what this is. So yeah, this is how you end every process successfully, so that you don't get error. If after that, if still you are getting an error, so you'll have to restart your system, and that is how it works. uh, I think now we can have like a small break, 5-10 minutes, and we'll be if like I had some instabilities in my system. If the code part works, then we'll do that, or else I think we'll end the session then. So I'll let you know about after 5 minutes. Till that time, you can have a break. All right, so yeah, my system is working properly, so I think we'll be using the code as well. So it will take like around, I think, most hardly 20 to 25 minutes to explain all that. Meanwhile, you guys can do is, if you have written the code for publisher, you can just revise that. I will be covering it anyways today, so yeah, no worries about that. So yeah, just like give me 2 minutes maybe. Yeah, so I think I will start. Um, just a minute. Yeah, let me share my screen. Uh, is it visible? Can someone please confirm?
It's visible.
Yeah, okay, fine. So, about yesterday, okay, is there like any disturbance from my side? Because I just increased the fan speed. If it's there, then I'll fix it. Is there, just can someone please speak up? Hello.
It's fine.
All right. So, okay. So this is what we did yesterday. Listener by, talker by. If anyone still has any problem, you can DM me. I'll give you like a proper explanation. Also, I have created a PDF which I forgot to share yesterday, so I'll just share it after this. And yeah, so we'll make a new file. Let's call it drone.py. And since it is just a normal executable script, we'll be playing with Mavros topics and all. So it doesn't matter if like where in which workspace it is. So hence we'll be using this because it is already set up properly. And yeah, so first thing is we'll write that initial line so that the terminal knows that this is a Python code. Then we'll import ROSPy as we did last time. Okay. Now, okay, now we need to like we'll make a small code to just set the velocity of a drone to something. And so for that we'll need, as we talked about Mavros topics before, so we'll need the set point velocity topic. So I'll just quickly go and I'll start everything. You can just do up arrow and you'll find all the previous commands that you used. And here I'll start Mavros. And also I'll launch QGround control. So yeah, one thing I would like to tell, the disadvantage of Arduino Pilot is that you'll have to launch all these files
Site mode.
separately. Okay, so I'm entering 4 commands in 4 different terminals. But if you're using px4, you can just create one launch file and everything will be started on its own. So that is one advantage of using the px4. But it is a bit difficult to learn as well as a bit difficult to install. So since you guys are beginners right now, so we just used autopilot for that. Okay, going to ROS topic list to see all the Mavros commands, Mavros topics that are available. We have Mavros set point velocity right here. I'll copy this so that we get to know what message we have to use, and we'll do a ROS topic info on this. So this is using geometry messages. This is the type of messages, and we'll just see what this message has in it. ROS message show. Yep. So header is not really relevant. It is just like a system info kind of thing, right? Like we saw log info day before yesterday or on Saturday. So it had some random numbers written on it and a time also. So that is what the header is. Then we have 3 angular and 3 linear components of velocities. So we'll import this message now. So to do that, we'll go to our VS Code and we'll import. Okay, so from geometry dot message import, the type was twist stamped. So if you write here twist stamped, it will come directly. So we have imported the message. We'll be using this message only, and now I think we can start writing the code. So let's call this function linear, and so let's just refer to the talker.py code so that we can create references. So first thing, we need to initialize a node and create a publishing object. So for that, I'll do, let's name our node linear only. So we'll do a rosspy dot init node, and let's name it linear. And yeah, also about the anonymous thing, by default anonymous is false. If you go on the init node, hover your mouse, you can see all the purple things are what it is set by as default. So we'll just, instead of writing anonymous.false, we'll just not write it because it is by default set to false. So we have initialized a node. Now we'll make a publishing object. So we need to publish velocity right here, right? So to create an object, we'll follow, like we'll use the publisher function dot publisher p capital. And okay, now here we'll be using the topic. We won't be creating our own topic. We'll be using the one that is given to us by Mavros. So if we go here in the terminal, this is what we'll be using. So I'll just copy this and I'll paste it here. Okay. Next thing what we did was we had data class. So here we'll be using twist stamp, not string, and we'll put the queue size as 10. Now we have our, oh, I forgot to put an equal to here. Yeah. So now we have our node initialized as well as we have our publisher ready. Publishing object ready, sorry. Now we'll define a rate. I think, like as I told you, 10 hertz is more than enough. So I'll just put rate is equal to rosspy dot rate with an R capital, and it will be 10 hertz. I'll just write it here. 10 hertz rate of publishing. Okay, now what we'll do is we'll make a message. We'll not make it, we'll modify the message. So let's create a variable. Like you might remember that we used to make like int a, so it will become an integer. A will become an integer. So similarly, let's make a velocity message, and it will be offered the type twist stamp. Right. So if you hover over this, you can see the twist stamp is a class, and the two fields that are available are header and twist. So if you go here, when we did ROS message show, so this is the header part, this much, and this is the twist part. right? So this is how our object, what we made here, the velocity message. The velocity message will look like this, and everything will have a value over here. So whatever it is by defaulted, it will have that, and we can modify our own values. So in the twist part, linear and angular are defaulted to 0. So we need to make it 1. So what we'll do is we'll just use, well, okay, yeah, one more thing. I think you all are aware, like how to access elements in a class. You can just put a dot, and then you can access whatever is within it, and so on. So since we want to access the twist part, so I'll write velocity dot message underscore message dot twist dot. So we need to modify the linear part. So now I'll write dot linear dot x. Let's make x velocity to, let's say, 5. Okay. Uh, Now after that, no, I think we are pretty much done with it. Now just we need to make a while loop for it. Here, the while loop will look a bit different, and that is because, like, it will do the same thing, but instead of writing while ROSPy is shut down over here, we'll write this while true, and we'll put a breaking condition that if ROSPy shuts down, then the loop will be broken. So I'll just write the breaking condition over here. If ROSPy dot is shut down, then break. And now we'll have to write the publishing part over here. So first thing, we'll set the velocity message to 5. So I'll just write that line over here. Also, take care of the indentation. There's no need of curly brackets, but if you write it in the wrong space, so if you write your velocity message over here, the while loop will end right here only, so that there's no use of that. So write your velocity message, like you do it 5, and now you want to publish this to the drone. So you made your object publish pub underscore object. So you'll just publish it, and to do that you can do pub underscore object and dot publish. Oops, publish, and this message is being published, right? So just write that here, velocity message. And then if the loop is, like, if ROSPy is shut down, then it will break. This is the end of while loop, and this is the end of our function. If you still, like, you can check the syntax over here. We publish the message, and then sleep is not really required here, because we don't want to do it continuously, and we don't want to wait for anything else, so we don't need sleep right now. Now I'll do the main function. I just copy it from here, nothing to change. So, or else, like, we don't even need to do that, because we just write this line if in it is main, if name is main, sorry, and we'll just execute our linear function. So this is the code of if you want to do the linear velocity in x direction as 5. It might seem a bit complicated and a bit of like overdoing stuff, but if you want to make like complex paths, like let's say helix, so instead of doing it on the Q ground control, it will be very easy to do it in this way. So let's save it, and since we added a new file, we'll go to our catkin workspace, and also we need to make it executable, right? So we'll do a ROS cd into our package. Our package name was beginner tutorials, and we'll go to scripts because that's where we have it, and we'll do a chmod plus x over here. I did an equal to x, sorry, plus x, start there. So now if you do an ls, you can see your drone.py is executable, and then you have to do a catkin build. Done. Now if I go to my gazebo, uh, yeah, okay. Oof. Yeah, so I'll just take off using Q ground control. 10
Guided flight mode.
10 meters
Arm.
is, I think, fine. Yes. Now it is in guided flight mode. So as I told, if it is in guided or auto, if you give any computer commands to it, it will listen to it. So I'll do a ROS run, beginner tutorial, ROS run, beginner tutorials, and it is drone.py. Hopefully it should run if the code didn't have any error. Permission denied. I think we made a mistake in doing a chmod +X. Just a second, I'll get back to it. I'll fix it and get back to it. Okay, so I think restarting everything should work here. Yeah. Also, like just a safety measure, I'll check the code.
Stabilized flight mode. Guided flight mode. Pre-arm. GPS. Waiting for home. Pre-arm. Lead position estimate. Pre-arm. Lead position estimate. Armed.
So I think there is an issue with Python in my system. So what we can do is we'll end this session here, and I think we'll get back to this on the next session. And the code is like correct. We just tried it before that, but yeah, then I think that is what we can do right now. So yep, thanks for watching. If any like doubts and all are there, you can just ask right. ये क्या रहा है? Okay, about 20.24. I'll send the commands on WhatsApp in like 15 minutes. I have it ready, but it is in my 20.04 system, so I'll just go there and I'll like put it on WhatsApp. Yeah.